Welcome to this course. I'm super excited to have you on board and to start this journey together with you. My name is Max and I'll be your instructor in this course. I'm a freelance web developer and I've worked with JavaScript for years and ages. Now, by the end of this course, you will also be an advanced JavaScript developer capable of applying for JavaScript jobs, working on your own project, or simply dive deeper into the JavaScript landscape and ecosystem and explore all the very advanced and niche features JavaScript offers. Now, this course is for everyone. We start at the very basics, no prior knowledge is assumed, but we'll also then build up knowledge and explore the more advanced and also expert topics. So no matter if you already have some JavaScript knowledge or if you're just getting started, this course is for you. Now, I'll not bore you with an entire overview of what's in the course in this lecture, because for that I'll have a separate lecture later in this module. There you will also learn about different entry points you can use based on your level of knowledge, because this is not just a complete guide, it's also a complete reference in the end. This course also is not a theoretical course. Of course, we have all the theory, but it's a practice-oriented course. There are plenty of opportunities for you to apply what you learned. There are quizzes and assignments and a lot of exercises and demo projects, because I strongly believe that you learn the most if you can apply things in real-world scenarios. You're also not alone. In this course, I'll always be there and I'll do my very best to ensure that you get out of the course what you want to get out of it. And with that, I'd say, let's not waste any time. Let's dive into the most important question right away and let's find out what exactly JavaScript is. So let's get started with this course and with everything you need to know about JavaScript by diving into this important question. What is JavaScript? Let's have a look at a couple of definitions. JavaScript is a dynamic, weakly typed programming language which is compiled at runtime. It can be executed as part of a web page in a browser or directly on any machine in a so-called host environment. Okay, not entirely clear yet? Let's have a look at an additional definition. JavaScript was created to make web pages more dynamic. That's kind of the idea why JavaScript was invented in the past, you could say. More about the history of JavaScript in a second, by the way. So it was invented to change the content on a page directly from inside the browser. And originally it was called LiveScript, but due to the popularity of Java back at the time, it was renamed to JavaScript to resemble Java by its name. JavaScript, however, is totally independent from Java. That's important to understand and has nothing in common. It really was just named JavaScript because, well, Java was popular and, people who invented JavaScript wanted JavaScript to be a thing, I guess. But I'm not sure. Are these definitions really clear? Do you now know what JavaScript is? Does dynamic, weakly typed, compiled at runtime make web pages more dynamic? Does this tell you something? Well, let's take a step back maybe. How do web pages work? You are the user visiting a web page, and when you do visit a web page, you use a browser for that. You use your client, your machine, your laptop, your computer, where you have a browser installed on it. You enter a URL or click on a search result on Google, and the web page gets loaded. To be precise, when you initially visit a web page, a request is sent to the server, so to a computer in the internet where that web page, where the HTML file is hosted, and that server then loads that web page and sends it back to your browser in a so-called response. And the most basic form of response we know or we typically see and use when we work with the internet, when we visit a page, is simply an HTML page which is sent back by the server to the client. Now let's say on that loaded web page, let's say it's an online shop, doesn't really matter, the user clicks a button to submit a form. For example, to order some products. Now this will then trigger a new request which is sent by the browser to the server to send this form submission to the server, and the server will handle that incoming request, maybe store some order data in a database, and once it's done, it will reply back with a new response, with a new web page, a new HTML document which is sent back to the client, maybe the order confirmation page. So this is how we interact with the web. This is how web pages traditionally work. Now, JavaScript helps us make this more reactive. It helps us make a web page more reactive and skip that second request response flow in some circumstances to instead change the already loaded page and do something there. Now let's simply see an example which should make this clearer. For that, attached you find a simple project which has 3 folders or 2 folders and 1 file. An assets folder, an info folder, and an index.html file. The extra folders and files you see here are just here in my local setup for version control and for my editor settings. And we can ignore them right now. You don't need them. They're not related to the web page. So we got 3 things in there, 2 folders and the index.html file. Now you can simply double click that index.html file and it will open up here in a new browser window, or it should at least. If not, open a browser window and drag the index.html file into it. Now this is a little dummy page I prepared for you. It holds some dummy information about this course and about me, your instructor. All this information is valid, by the way, but of course we're not building this web page here. Right now this is mostly HTML and CSS, or to be precise, it's pretty much all HTML and CSS at this point. And you can always go back to these files, and in the assets folder, you'll find an images folder with my image. You'll find a styles folder with the CSS files. And if you would look into the index.html file, for example, by right-clicking on it and opening it with a text editor, and you can use either text edit here on Mac or the normal Notepad or text editor on Windows. If you are using text edit on Mac, go to preferences here, and on open and save, make sure you check this display HTML files as HTML code instead of formatted text box. Then close this and reopen with text edit. And this only applies to Mac here. And you will see the raw HTML code. So this is a bunch of HTML code here. But what you won't see in there is anything JavaScripty in this file. It's just HTML and some imported CSS styles. This leads to this page. And here on this page, we have these 2 links, dynamic interpreted and weakly typed. And if you click on any of these links, you're taken to a new page. Here's the dynamic page, where we see a more detailed explanation. And here's the weakly typed page. Now what we have here is a traditional web page, and what we also have here is a new request being sent to a server if this were served by a server instead of our local file system, and a new page being loaded, right? We're always loading a new page here. Of course, there's nothing wrong with that, but a more modern way, a more user-friendly way of doing that might be to not load a new page here, but instead to show this piece of information maybe in an overlay to the existing page, such a modal as it's called, a little pop-up like window which gets loaded as an overlay on this already existing page, so that we don't need to fetch a new HTML page and break the user experience a bit therefore, but instead that we stay on this existing page and only tweak it a little bit. So we kind of need to tweak the existing HTML code, this code here, which was loaded by the browser, whilst we are on the page, so without loading a new HTML file. That's the idea, and that is where JavaScript can help us and why JavaScript was invented and why it is so important these days. Because any modern website you visit, all these exciting user interactions you have there with drop-downs, with overlays, and so on, all of that is driven by JavaScript. And we can turn this page here into a more exciting page as well. I prepared something for you. You might have noticed that in this starting code I provided to you, in the assets folder, you also have a scripts folder with an app.js file. .js stands for JavaScript, and this is how you store JavaScript code in JavaScript. Now we can of course also inspect that file by clicking on Open With, and then also text edit. And what you see in there is JavaScript code. Now at this point of time, of course, You won't understand all this code. Maybe you understand none of that if you have no previous experience with JavaScript, and we'll of course change that throughout the course. We'll start at the core basics, and you will understand all this code once we progress throughout the course, and of course once we completed the course. But for now, we can just take this code for granted, close this file, and ignore it. And instead, let's go back to our index.html file, to the source code we opened here in the editor. And below this link here, where we import the app CSS file, above the head here, let's add a new HTML tag. Script, also a closing tag for it. And then add a src attribute to script here, and point at assets/scripts/app.js. So at this JavaScript file we just had a look at. That alone won't do the trick. Let's also scroll down a bit and go to these two links we have here, to the dynamic interpreted and the weakly typed link. Now there, let's remove that link to info dynamic HTML and add a hash instead. And instead add a new attribute here, data-text, to this anchor tag here, equals, and then double quotes. And now let's go to the info folder and then to the dynamic HTML file, open that with the text editor, and simply grab the text you have in there between the paragraph tags, excluding the paragraph tags, and copy that and paste that here between the double quotes. Now make sure you get rid of any line breaks you might have in there, because that will not work, so that this is all one long line of code in the end. And thereafter add one more thing to the anchor tag, class, to add a CSS class, info-modal. Now repeat that. We can copy all of these attributes on the second link and replace its reference with the hashtag reference as well. And the text we show there should of course now be the text we find in the weakly typed HTML file. So if we open that with the text editor, let's grab this text here we find in there, copy it, and also replace the text here on the second anchor tag with this text. Now again, make sure you get rid of any line breaks you might have here, because these will break your code. Now with that, let's go back up to our script import and add one important word here after the src attribute, and that's the defer attribute. This controls how and when this JavaScript code is executed, and I'll dive back into this a little bit later. For now, let's just add it, then save this whole index.html file, go back to your page and reload it by simply clicking the reload icon here, and then click on one of these links. And now you will get this nice overlay here, which you can also close by clicking on that backdrop. Now what we have here is new content, which is dynamically added to this existing web page by JavaScript. We're not loading a new web page here. Instead, this overlay is shown by JavaScript. And this, of course, is a way better user experience, because now we don't send the user off to a new page. We don't wait for new HTML code to be downloaded. We change the existing page. And this is something you see on a lot of modern web pages, because it's faster. It's more like in a mobile app where you also don't have to wait for things to complete. And therefore, this is one of the core reasons why JavaScript is that important. It allows us to make web pages more dynamic. So if we come back to that question of what JavaScript is, if I quickly dive into the core things we learned on this previous slide, JavaScript is a dynamic, weakly typed programming language. It's an interpreted language, which means it's compiled on the fly. It's compiled before it runs and not compiled during development as some other programming languages are. It's a hosted language that runs in different environments, though thus far in the last example we just saw it run in the browser, but I'll come back to other environments in this course as well. And the most prominent use case is the case we just saw. We run code in a browser on a web page to make that more dynamic. So now we understand why we use JavaScript and what it allows us to do. But what do these terms, dynamic, weakly typed, and interpreted, as well as hosted language, mean in detail? Let's have a look at this interpreted, on-the-fly compiled thing. How is the JavaScript code in our browser executed? And not just in our browser, but typically in any environment where you run JavaScript. Let's say you write your JavaScript code and you want it to have some effect on the web page if we talk about the browser as the environment where we run our script. Then you have one important thing built into any environment where you want to run JavaScript code, and that's a JavaScript engine. It's built into the browser, as I said. There in Chrome, for example, in the Chrome browser, it's V8, that's the name of the engine. In Firefox, the name would be SpiderMonkey. And of course, other browsers also either reuse these engines or have their own engines. Now, the job of the engine is to parse code, so parse, read, and understand your JavaScript code. Then, on the fly, compile it to machine code, because machine code executes faster. So it reads your code, but it does not necessarily execute it like that, but instead it now takes that code and compiles it to code, which is faster to execute by the machine, and then it executes that machine code. This all happens in the browser with the help of the JavaScript engine. And then when that code is executed, we have that effect on our web page. Now, important modern engines have a lot of optimizations there. They might start executing your uncompiled code and then compile the code whilst they're also already executing it to get started executing faster and then switch to the compiled code dynamically and so on. So we have a lot of optimizations going on here, and we will dig a bit deeper into what the JavaScript engine is exactly in a separate module in the course. For now, this is all we need to know. The browser has a built-in tool that takes our code, compiles it, optimizes it, and executes it. And also a bit more technical side note, all of that happens on a single thread. Now, this is very technical, but you might know that in a computer, you have certain tasks that are executed. For example, the browser you opened is a task, or actually it might consist of multiple different tasks that are executed together. The JavaScript code is also yet another task which your operating system in the end has to take care of. And this runs on a single thread. Of course, we have multi-threading on modern machines so that they can do multiple tasks at the same time, but the JavaScript code execution runs on one single thread there. So the JavaScript code execution always happens in one single thread on your operating system. Right now, this doesn't really matter. It will become more important later in the course, though, when I will come back to this concept of single threading and which implications this has for JavaScript. But with that, we know what interpreted means, what compilation means, and how the JavaScript code is executed. What does dynamic and weakly typed mean then? JavaScript is a dynamic interpreted programming language, but it's also a weakly typed programming language. Now, what does this mean? For one, the dynamic interpreted part, as you learned, means that it's not pre-compiled. Other languages, like C++, are compiled during or after development, so before you share them with the end users. JavaScript is on-the-fly compiled. And that means that the code is evaluated and executed at runtime. It also means that the code can change at runtime. Now, of course, not the code you wrote, it won't magically change. Of course, the code you wrote gets executed. But in that code, you can do some things which you're not allowed to do in other programming languages. For example, if you're working with a variable, something we will only learn in the second module, for now you can just keep in mind that a variable is a data container. You might store, let's say, some text in there. Text you need in your script to, for example, output it to the user. In JavaScript, you are allowed to dynamically switch the type of data there. In a variable, you might start by storing some text, and suddenly at a later point of time, you store a number in there instead, in the same variable. Now again, we haven't really learned about variables yet. We will, of course, do that. But the one thing you can simply keep in mind is that the dynamic thing in JavaScript means that it is parsed and interpreted and compiled at runtime, and that therefore it is able to do certain things. For example, switching the data of a variable other programming languages are not allowed to do. Now, it's not necessarily good to switch the type of data dynamically or unexpectedly, but you can do that. The main takeaway, however, is the on-the-fly compilation and interpretation. Now, what about the weakly typed part here? This means that when we work with data in JavaScript, for example, text data or numbers, you don't have to tell JavaScript that you're going to work with a text now or you're going to work with a number now. Instead, data types are assumed, are inferred automatically, so to say. That's also related to this dynamic nature where data types can also change from one line to another. Now, this might sound strange, but in other programming languages, you have to define the type of data a variable will hold in advance. In JavaScript, that's not the case. You don't have to tell JavaScript that this variable, this data container, will hold a number. Instead, you store a data in there, and if that happens to be a number, so it is. In other programming languages, you have to tell the language that you're going to store a number in there, and if you store something else, you would get an error. That's not the case in JavaScript. It's forgiving there because it's dynamic, and it also doesn't care about strong type definitions in advance. Instead, you just store data in there and go with whatever type of data that holds. So data types are not set in stone, but can change. Now, this is arguably a bit more advanced. I just want you to be aware of these terms, dynamic and weakly typed right now, and they will make more and more sense as we progress throughout this course and work with data and variables. For now, just be aware of these terms. Now, the last thing we saw on the previous definition slide is that JavaScript runs on a host environment. So that means a JavaScript engine can be part or can be executed in different environments. The most well-known environment is the browser. Modern browsers have JavaScript engines built in, and they're therefore capable of executing JavaScript code. But you also can run JavaScript in other environments, for example, on the server side. So right on a computer without having a browser in between. So not inside of a browser, but simply execute code like this on your machine. Now, JavaScript was invented to run in the browser to make websites more dynamic, to be able to change things on a website without loading a new page, you could say. Because JavaScript is able to closely work together with the loaded HTML code, with CSS. You can also use JavaScript to send background HTTP requests, so to send some behind-the-scenes requests and fetch data without reloading the page, and much, much more. And we'll do all of that throughout the course. Now, there also are certain things JavaScript can't do when it runs in the browser environment, though. For example, it can't access your local file system for security reasons, because otherwise every web page you visit would be able to read your file system, maybe delete files on your computer, and so on, which would be horrible, of course. And in general, it is running in a sandbox, you can say. It's not able to interact with your operating system and so on. The browser gives you certain things you can do in this environment and doesn't allow other things. Now, as I said, the browser is only one environment, though, the one for which JavaScript was invented, but not the only one we're restricted to right now. Instead, the JavaScript engine Google developed, V8 is the name of the engine, was extracted by some people to run JavaScript anywhere. Because the idea was, well, if we have the engine in the browser, why don't we take it out of the browser and then make it available as a standalone tool which you can use to execute JavaScript anywhere else directly on your machine. And this tool is in the end called Node.js. Now, in this course, I'll have a separate module about Node.js where I show you how that works and how it uses the same JavaScript syntax you learned throughout the course, but which new features it brings to the table. For the majority of the course, however, we'll focus on the browser side because this is the side where you absolutely need JavaScript, and it's also the side where you're able to see more because you have a web page where things change and so on. Now, back to Node.js, though, for a second. Node.js can be executed on any machine, and therefore it's also often used to build web backends, to build web servers. Server-side JavaScript is also something you often hear as a description for that. Now, you might know about server-side languages like PHP, or also Java and other languages as well. Well, JavaScript with Node.js can also be used to run it on the backend of a web page, so on the server and not on the client in the browser of your users. Now, Node.js also has certain things it can do and can't do. Since it runs directly on a machine, In Node.js, you're able to access the local file system, so you are able to write files and so on, because unlike browser-side JavaScript, Node.js code has to be executed actively by you. It's not like you visit a web page and then this starts happening. Instead, it can only access the file system on the machine where it executes, which, for example, is the server where it runs, not your machine. And it's also able to interact with the operating system and so on. However, on the other hand, since it doesn't have direct access to the loaded web page, it can't manipulate HTML or CSS like browser-side JavaScript is able to do. So we basically have inverse access capabilities here. And these are the different environments where JavaScript is able to run. Now in this course, we'll focus on the browser side because the JavaScript syntax you learn will be the same no matter in which environment you run JavaScript code. But in the browser, we simply have more visual feedback and can see what happens. Nonetheless, as I said, we have this separate Node.js module later in the course where I'll also dive into the different things we can do in Node.js and how that works. So we saw some JavaScript in action. We have the basic definition out of the way and hopefully now have a basic understanding of what JavaScript is and what this language is all about. Now, what's in this course though? What will you learn in this course? You could split this course into 3 main blocks, I would say. The core basics, which you have to know under all circumstances. Then the next block where we build up on these basics and build a really strong foundation. You could therefore still call that basics, but these would be the advanced basics. And then we have advanced concepts, which allow you to get to the next level of JavaScript development and become a really good JavaScript developer. Now in the core basics block, we get started. This is this module. We learn the core basics about JavaScript and its history and so on. But once we're finished with this module, we'll dive into all the core syntax, the language basics, into variables, functions, what all of that is. All these core things that make up the JavaScript language, which you have to know no matter in which environment you want to execute JavaScript. We'll dive into efficient development and debugging, how to configure your environment correctly, how to fix errors and how to find them. We'll dive into control structures, if statements, loops, so that you can execute code multiple times based on some conditions. We'll look behind the scenes of JavaScript. We'll see what the JavaScript engine does in detail. We'll have a closer look at functions, a very important concept as it will turn out. We'll have a look at DOM basics. DOM stands for Document Object Model, and this will all be about manipulating the web page we're running on, adding content, removing content, and so on. We'll have a look at arrays and iterables, so at lists of data and how we can work with those. We'll have a look at objects, which are super important data structures in JavaScript. And once we're done with that, you will have a solid basic understanding of the JavaScript core syntax and the core features. Now thereafter we'll build a stronger foundation, and if you already know all the core-based syntax, this of course might be a great entry point. You'll find a module in the curriculum, if you check that, about classes and object-oriented programming, which takes object usage, you learned about objects in the core basics, to the next level. You'll learn about constructor functions and prototypes, important core concepts baked into the JavaScript language. We'll dive deeper into the DOM and how to work with the browser and tap into certain browser features. We'll dive deeper into events, how we can react to mouse clicks, and so on. We'll have a look at functions again. We'll dive really deep into functions and learn about things like recursion and more advanced function usage. We'll explore the number and string types in greater detail and which restrictions we have there and what we can do there. We'll dive into asynchronous code, which will be related to that single threading I mentioned, and how we can run longer taking operations without freezing our web page. We'll dive into these background HTTP requests, also sometimes referred to as AJAX, which I mentioned earlier, which allow us to exchange data behind the scenes without reloading the page. And once we did all of that, we will have a very solid foundation, not just the basic core syntax, but we'll also know all the important parts of the JavaScript language and of using JavaScript in the browser. Now, of course, then we'll also dive into more advanced concepts. You will learn how to work with third-party libraries, how to utilize JavaScript modules and split your code efficiently across multiple files. We'll dive into tooling, which allows us to optimize our JavaScript code, namely Webpack and Babel. We'll briefly dive into browser storage and how you can store data in the browser. We'll have a look at browser support and how you can ensure that your scripts run in all browsers where they need to run, no matter which browsers your end users are going to use. We'll have a look at JavaScript frameworks, and there we'll have a look at the React.js library. We'll have a look at metaprogramming, how you can write code which is easier to use by other developers, really advanced but really important. We'll have a look at Node.js and see how that differs from browser-side JavaScript and what will be the same. We'll have a look at security and how you secure your code and which security holes you want to avoid. We'll, of course, also see how you get your code from your local machine onto a server where other users can use it. We'll have a look at performance optimizations and fixing memory leaks to ship the best possible code, and much, much more. This course is a big course. It has a lot of hours of content because it's simply packed with content. You can simply go from lecture 1 to the last lecture, or of course also dive into the modules which are most interesting to you. I did my best to build the course in a way that allows you to also use it as a reference, so that you don't always have to restart at the beginning if you are coming back to it after a year or so, but that you can dive into the sections which are most interesting to you. Though if you are new or relatively new to JavaScript, my strong recommendation is that you start with lecture 1 in section 1 and you go through the course step by step, maybe just speeding up playback if I'm going through some concepts you already know. So this is what's in the course and how you can take it. I also want to make sure that you get the most out of this course though. And for that, of course, you should watch the videos. Watch them at your speed, use the playback controls, the speed controls in the video player to speed me up if I'm going too slow for your taste in a certain video or on a certain concept, but also slow me down if you need more time. Also pause and rewind if a certain concept is not clear yet. It's a video on demand course, so take advantage of that. You can watch a video more than once. This is absolutely fine. Also, code along. Pause and rewind, as I said, if I'm going too fast, and also pause regularly to try implementing what I'm about to implement on your own first. This is the best way of practicing. I also got tons of quizzes in this course which you can use, because practicing, of course, is important. So do the assignments you find, follow along in the practice projects we dive into, and do the quizzes to check your knowledge and make sure that we're all on the same page. Also, of course, if you're facing errors, if something does not work as expected, use the knowledge you gain in the development and debugging section and debug your code. Search for errors and also search for solutions. You can use the attached code snippets, which you find attached to multiple lectures per module and always to the last lecture of each module, to compare your code to mine. If something is not working as shown in the video, chances are that there is a difference in code, and comparing code is what you should do in that case to find and fix the error. You can also replace your code step by step with mine temporarily to narrow down the issue. But also Google error messages if you find them, and use the search built into the Udemy course player. That allows you to also find many common issues and fix them on your own. But of course, if you're stuck or if some concept is unclear and you're not able to proceed on your own, also ask and answer. You have a Q&A section in this course, and there you can ask questions, and I will read and reply there regularly. But also use it to help others, because you will learn the most if you don't just ask, but if you solve problems on your own, and if you also help others solve problems, because that forces you to think about an issue and find a solution, and that ultimately is always how you learn the most. So now, before we dive into the next module, where we dive right into the language, let me dive a bit deeper into the history of JavaScript and where it's coming from. And there, let's also have a look at that comparison between JavaScript and Java again. Now, Java and JavaScript are two totally independent programming languages. That's really important. They have a totally different syntax, different principles. They have almost nothing in common besides the name, I would say. Also, JavaScript runs in the browser, and as you learned, also in other environments. Java does not run in the browser. You can use it on the server side to render HTML dynamically there and send it back to users. You can also use it in a non-web development context, but it is not supported directly in the browser. You can't use it for the same things as you can use JavaScript. You also, as I mentioned, have different principles. Java, for example, is strictly object-oriented and strongly typed. There, you need to define which kind of data you're about to store in a data container. Whereas JavaScript is really flexible, you don't have to work with objects only there, and we'll dive into object orientation and what that means throughout the course, no worries. And it's also weakly typed as you learn. Now, JavaScript was named JavaScript to sound cool, you could say, because Java was a big thing, and JavaScript kind of was inspired by it, but is totally different then in the end. And, well, people just wanted to have other people use JavaScript, I guess. Java does not run the browser, as I mentioned, though. That's really important to keep in mind. JavaScript does. And speaking about that differentiation between client-side and server-side JavaScript, client-side means in the browser, server-side, with the help of Node.js, means on a machine that is connected to the internet, which might be serving web pages, but which doesn't run code directly on the machines of the end users. And the client-side part is really the origin of JavaScript. And as you learn, different browser vendors, so different companies developing browsers, provide their own JavaScript execution engines. For example, the V8 engine, that's the name of the JavaScript engine Chrome uses. And the important thing there is that in the browser, you are able to interact with the web page from inside JavaScript. You can manipulate the loaded web page. You can also use certain browser features, so-called APIs, for example, to get the user location. On the server side, the idea was to, well, extract the engine out of the browser and allow you to run it outside of the browser so that you can reuse your JavaScript knowledge, but now use JavaScript for different tasks. And you can now run JavaScript anywhere with Node.js, for example, on a server side. And there you have special other features, other APIs you can tap in, for example, to work with the file system or handle incoming HTTP requests. Now, the syntax, concepts, and core features are exactly the same though. Therefore, what you learn in this course, where we primarily focus on the browser side, since it's simply also easier and more visual to use, are the same. What you learn in the browser applies to Node.js and other environments as well, as you will also see in the Node.js section. So that's why we start with the browser side. It's JavaScript's origin. There are no alternatives to JavaScript in the browser, so you might not be interested in using JavaScript on a server. If you are interested in front-end, in browser-side web development though, you have to learn JavaScript because that is the only programming language you can use there in the end. You can then transfer your knowledge because Node.js uses the same syntax, so you easily learn Node.js after learning JavaScript in general or in the browser. And it's more fun to learn JavaScript if you see something on the page. So now that we know what JavaScript is and where it runs, let's have a very brief overview of the JavaScript history so that you know how it evolved over time. In 1995, Netscape introduces LiveScript, which thereafter was renamed to JavaScript. Now, in 1996, Microsoft also released its own version of JavaScript in Internet Explorer. So same idea, generally same syntax, but also differences. So we already had an issue there. Back then, JavaScript also wasn't able to do a lot of things. It was mainly used for spammy things, for annoying overlays and pop-ups. But another problem was that you had to write very different scripts for different browsers. In late 1996, people saw that this fragmentation could be a problem, and therefore JavaScript, the language, was submitted to the ECMA committee to start standardization. This simply is an organization which was then responsible for standardizing JavaScript so that you have one standard which then could be implemented by multiple browsers. So then we had ongoing standardization efforts until 2005 roughly, and Microsoft didn't really join the party. Well, we know how Microsoft was in the late 90s, early 2000s. Ultimately, they supported the standardized JavaScript version. Still, there were differences, but we had a more common way of using JavaScript. Now, the efforts of standardization continued, and we had huge progress until 2011, I'd say. And Microsoft eventually joined forces and became part of the standardization process and of contributing to building that standard and adding new features. Because that's important. My timeline ends here. The development of JavaScript absolutely does not. I would say, especially since 2010-11, it really picked up. And it is under active development. It's evolving, new features are getting added, it's getting a better and better programming language. And whilst it was quite clunky around 2006 and 2007, and despite standardization, every browser still did its own thing in some regards, we nowadays really have a uniform language with some small differences, but mainly one core language we can use in different browsers. Still, different browsers have their own features you can then use, but the core language is the same. And in the browser support module later in the course, I'll explain how you find out which differences we still have and how you work around them. But in the end, we now have a standardized language which is really great to use. We have that thanks to this ECMA international organization. Now, this organization in the end manages a language called ECMAScript. But ECMAScript and JavaScript actually have a strong relation. ECMAScript is the actual language which is evolved by the ECMA international organization. But ECMAScript is then implemented as JavaScript by browser vendors, so by the companies working on the browsers. So it is the most famous ECMAScript implementation. JavaScript is that most famous ECMAScript implementation. Others would be ActionScript or JScript, and you don't really need to know those. So JavaScript in the end is ECMAScript, we could say, and we have that organization that evolves ECMAScript, and with every new standard version, you could say, which is in the end then created and finalized, browser vendors take that and implement it into browsers. So ECMAScript itself isn't directly used, but browser vendors implement it into their JavaScript engines. Each browser comes with its own JavaScript engine though, and therefore it's each browser and the engine used by the browser which defines which exact features are supported. And actually browsers also sometimes implement certain features at an earlier point of time than they're really finalized in ECMAScript. So whilst discussions might still be going on over final implementation details, browser vendors could already go ahead and implement a certain feature in their engine already, so that you can already use next generation JavaScript code earlier in one browser than in the other. And that's also something I'll come back to in the browser support module, where you will learn how to use next-gen JavaScript when writing your code and still ensuring that it runs in all browsers. So ECMAScript is under active development, and browser vendors are contributing there as well, are shaping how JavaScript looks like and which new features we want there. And therefore JavaScript is under active development, and therefore it's an always evolving language. Now in this course you will learn JavaScript in the most modern way you can, using all the latest modern syntax. And this is important because in 2015, 2016, JavaScript saw a major overhaul, a brand new version, you could almost say, with a lot of important changes. And many tutorials and courses actually teach you the old JavaScript syntax, which still works, but which is not the most recent one, and which has certain downsides. And then they later switch to the modern syntax. In this course, you will learn the most modern syntax right from the start. I will also show you the older one, because you will still see it in other tutorials and code snippets, and you should be able to understand those. but we start with the modern one and we stick to the modern one. So you learn all the latest JavaScript in this course. Now, hopefully you're now excited to get started, and so am I. Before we get started, we just have to make sure that we have a proper development environment. So a good environment where we can write code and dive into JavaScript. Because writing code in a system text editor, as we did it earlier in this module, is really too cumbersome, not really a great experience. If we have a look at that, well, this is really hard to read. And if we write a lot of code there, that's not fun at all. So we need a better code editor, which makes working on our code easier, which takes some work off us, and makes it more pleasant in general. And we also need an environment where we can test our web page and our code. Now, for the editor, I strongly recommend using Visual Studio Code. This is not the only code editor or IDE for integrated development environment which you can use, but it is free and it's really, really great. It's super fast, very modern, under active development, really extensible and customizable. It's my strong recommendation to use Visual Studio Code, and we'll install it together in just a second. You can combine it with a lot of extensions, which you can install from inside Visual Studio Code, and you can configure it to suit your needs. And I have a module where we'll dive deeper into that, but I'll also show you a basic setup, which I use right in this lecture. Now, for testing and seeing our code in action, we also need a browser, and there I recommend using Google Chrome. Of course, we will write code that runs in all browsers we want to support. More on that in the browser support module. But for development, Chrome is really amazing. It has a lot of features that make development easier, and my strong recommendation therefore is to use Chrome for development, even if you normally use a different browser. Really use Chrome to have the same result as I do here and to follow along smoothly. Again, later you will learn how to make sure that the code runs in all browsers where it needs to run. Now, in Chrome, we will also use the developer tools which are built into Chrome to have a look at our code, debug it, and so on. And I'll also have a look at that in the development and debugging section later in the course. But with that, let's get started with the code editor, with the IDE, with Visual Studio Code. For that, you can simply Google for Visual Studio Code, and you should find this page, code.visualstudio.com. There you can learn more about this code editor, and you can always check out the docs if you're interested in diving deeper. And of course, you can also download an installer. Here, it should already pick the right one for your operating system. Otherwise, choose one from the dropdown. Visual Studio Code is available for Mac, for Windows, and for Linux. Simply download the installer from this page, where you then also see some getting started instructions, and run through the installation process once you did so. It's a straightforward installation process, nothing fancy about that. You can just go through the downloaded installer and install Visual Studio Code on your system. Once you did that, you can open the editor, and it should look something like this. Now, if it doesn't have this dark mode look here, you can change the theme by going to your options here, Preferences, and then Color Theme, or using the shortcuts you see there. Under Windows, you will find the preferences under File. When you choose Color Theme, you can pick a theme and you see a bunch of themes available. You can simply cycle through these themes with the arrow keys and check out which theme you want to use. Now, I like this Dark Plus theme, but of course you can go with the theme you like. You also see a bunch of elements here at the start. You can also customize this under View, Appearance, and there, for example, you could get rid of that status bar at the bottom if you wanted to. Now, I will add it back, but you can tweak this to your likings to make sure that you see the information you want to see. Now, as you see, we don't see our code here. So we can click Open Folder here, or choose File, Open, and then choose the folder you do want to open. And here, I chose the folder with the starting code we saw earlier in this course. You find it attached to this lecture again. Simply open the whole folder, and now this will load this project into Visual Studio Code here. Now, the colors of these files might look different. That has something to do with version control, something we don't have to worry about right now. But you should see these files and folders here. Again, you won't see the gitignore and VS Code file here. These are folders and files only I have here for my configuration. You should see the assets, info, and index.html folders and file though. Now, what might also be different for you, however, is the icons you see here. Now that's coming from a so-called extension I added. Extensions are plugins you can add into your editor to change it and tweak it to your likings. You can add plugins and extensions by going here to this extensions part. You can also get there by clicking on View, Extensions, and that's actually how I will navigate, and I will remove that activity bar here on the left and just navigate around with View, and then here these shortcuts or these options, and now we're on the extensions part. Now I already got a bunch of extensions installed. Most of them are not required here for this development, but there are some which I do recommend using. And one is the material icon extension. You can just search for material icon and you should find the material icon theme package. Now this is totally optional, but you can install it. You will have an install button here to get the same file icons as I do. So you can install it and then load the extension with the buttons you see here to add the same icons. Another extension I recommend using is Prettier. You can search for Prettier, written like this, and install and enable this extension. This is an extension which helps us with code formatting. Now, code formatting allows us to write clean and well-readable code. Because as you will see, a lot of code is valid from a technical perspective, but can be hard to read. I'll show you an example in a second. With that, we have all the core extensions I would recommend here. You don't need the other extensions I have here. They're not even related to JavaScript development necessarily. And therefore, we should be good here. You can now go back to the Explorer view here to see your files again. And now let me show you how you should basically configure your project and what this code formatting is all about. For that, let's open the assets folder, scripts and their app.js. And there you see the script I'm giving to you. Now, you already see here why we're using a code editor. This, and all's in the HTML file, is much more readable than this here, right? It's much more readable, keywords are highlighted. We also get information if we hover over something. We get useful auto-completion if we type, and so on. And you'll see all of that throughout this course as we write code. You don't need to understand this code here, of course. We will learn all about that throughout this course. But I want to show you this auto-formatting. Let's say here in line 6, I don't have this white space at the beginning, or I even have code like that. Technically, this is valid code. I can already tell you that. JavaScript is able to understand and execute this code. But to us humans, it's a bit harder to read. And that's where we can use so-called auto-formatting. If you go to Code, Preferences, Keyboard Shortcuts, and there you search for Format Document, you will find this shortcut with a certain shortcut attached to it. If you don't have one here, you can right-click on this and change the key binding to assign a shortcut. And this is a shortcut you can then press to auto-format your code. You saw that? The code magically changed to a more readable version. This is something where Prettier helps us. Now, in general, of course, you can tweak your keyboard shortcuts here, not just the format document, but any shortcut you might be using here in these settings. And you got a lot of shortcuts you can use. Of course, you can use the official documentation to learn all about Visual Code already if you want to. I will also share some useful hints with you in the development and debugging section later in the course. One thing which I would recommend that you do is that you also dive into Preferences settings right now, though. And there you can switch between user and workspace settings. Basically, user settings are settings that apply to all projects you manage with Visual Studio Code. Workspace settings only apply to this project. For example, here I got a workspace setting, and that's where this .vs code folder is coming from, where I set the zoom level to 6 so that this is more readable to you. That's all I have in there. Now, under Preferences settings, you can tweak your user or your project-specific settings. And there, for example, you can search for Prettier and configure Prettier here, as you see, and the various options it offers you to format the code as you want. For example, some things I have set up there is that I want to add semicolons at the end of every line. I have this checked. I have single quote checked to use single quotes for text. And I have a tab width of 2. Now, this is not something you have to do. These are just my settings in case you want to have the same code output as I have it here. And with that, we have a basic editor setup, which we can use to write our code throughout this course. Now let's come back to the browser. As I said, I recommend that you use Chrome there And you might want to use incognito mode to avoid any distractions by any Chrome extensions you might have installed, which might interfere with your web page and maybe do something which is not caused by your code but by some extension. Also important in Chrome are the developer tools. You can get there by using View, Developer Tools, or the shortcut which is shown there. And these are the developer tools we'll also spend a lot of time in. I'll zoom in a bit here to make it a bit bigger. And there, for example, we have this console where we can output some development log messages, something we'll do throughout the course. We have the Elements tab where we can see the rendered HTML content, and so on. Now, one important setting I want you to make here in the developer tools to also have the same output and behavior here as I have it. In the console area, if you click on the gear icon here, make sure preserve log is not checked. This simply makes sure that whenever you reload the page, this log will be emptied and we see a new log output for the currently running page. Now that's all. Now we'll have a closer look at the developer tools in a separate module. I just already want you to be aware of them, and I want you to make sure that you use Chrome and have a properly set up editor. And with that, we're all set. We can now dive into JavaScript, its basics, and get started learning this amazing language.